Hello, so today we're going to be looking at this reaction right here, and we're going to be trying to write the rate law. So if we look at our reactants, we have hydrogen and nitrogen monoxide. So our rate law will be some constant time, the rate constant times the concentration of hydrogen to some power and the concentration of nitrogen monoxide to some power. So now let's take a look at these experiments and see and try to figure out what power they should be. So between these two trials, the concentration of nitrogen monoxide is constant, and we are doubling the concentration of hydrogen. And if we look over here, we'll notice that that doubles the rate. So if we're doubling the concentration of hydrogen and doubling the rate, that means that the power of hydrogen is 1, because 2 to the first power is 2. So now let's take a look at nitrogen monoxide. So these two hydrogen concentrations are constant between these two trials. And we'll notice here that we are doubling our concentration of nitrogen monoxide. And if we look here, we will notice that we are quadrupling the rate. So that means that the concentration of nitrogen monoxide is to the second power. Doubling the concentration of nitrogen monoxide results in quadrupling the rate. So there we go. There's our rate law. Now, how about we try to figure out the rate constant? We know we're given the rate, the concentration of nitrogen monoxide, and the concentration of hydrogen, so let's just plug in. So 2.4 times 10 to the negative 6 is equal to the rate constant, 0.010 molarity. Nitrogen monoxide is 0.025 molarity, and it's squared. So now we do some math, and we will see Rk is 0.384 molarity to the negative 2 seconds to the negative 1. And there we go. So that's Rk. And now, how about we try to propose a reaction mechanism? So if we look at our rate, we'll notice hydrogen is to the first power and nitrogen is to the second power. So how about we just make things simple and assume that 2 molecules of nitrogen monoxide are colliding with 1 molecule of hydrogen. That will give us this rate law. So we'll have 1 molecule of hydrogen colliding with 2 molecules of nitrogen monoxide. And we will say that that gives us nitrogen gas plus 1 molecule of water and 1 oxygen atom. And so let's look up here and we'll notice we have this nitrogen right here already completed. We have one of the waters. We need a second water. And we used up both of the nitrogen monoxides and we used up one of the hydrogens. So we need to use up one more hydrogen, and oxygen is our intermediate, so we need to use that. And we are creating the less water that we need. And so there we go. And this will be the slow step, the rate determining step. And the second one will be the fast step. And as we can see, one molecule of hydrogen colliding with two molecules of nitrogen monoxide will give us this rate law right here. So this is a plausible reaction mechanism.